Hi y'all, Raya here, and today we're going to be tackling a quick AP Calculus AB FRQ question. To be specific, we'll be going over number 4 on the 2016 test. Without further ado, let's begin. So, we're given the differential equation dy over dx is equal to y squared over x minus 1. And just like any separable equation, our first order of business shall be to draw a bit of the slope field. This is relatively easy, so I won't be going into too far into depth as to what I'm doing here. You're just plugging in the coordinates at each point and getting the slope. But it is worthy to note that the numerator is a sole y squared, indicating that almost all points on the x-axis will have a flat slope, save for 1, 0, which is indeterminate. The grading on these problems are relatively loose as well. Just be sure you can see what slopes are positive, negative, and 0, and you should be good to go. That should be no problem, so let's go on to part B. In this part, they essentially give us they tell us to use a particular solution and a point f of 2 equals 3, and they ask for the linear approximation through said point. The slope of the function at this point is merely dy dx, so instead of finding what the particular solution is, the key to this problem is just using the separable equation to get the slope for us. Plug in x equals 2 and y, or just f of x, or just y, equals 3, and you can get the slope of 3 squared over 2 minus 1, which is 9. The rest should be easy. With y 2, 3 and our slope, we can deduce the equation of the linear approximation as y minus 3 is equal to 9 times x minus 2, or y is equal to 9x minus 2 plus 3. Then, since the second part asks for the approximate value of f of 2.1, given our linear approximation, we can just plug in 2.1 into our equation, and that gets us 3.9. Just remember not to overthink it on these types of problems, and you'll be fine. Onwards. Part C. Find the particular solution, y equals f of x, for the given differential equation with the initial condition f of 2 equals 3. Ah yes, the meat of the problem. Let's get straight to it. Start with the separable equation dy over dx is equal to y squared over x minus 1. As is its namesake, separate the y and the x. Doing some multiplication, we get 1 over y squared, which is just y to the negative second, dy, is equal to 1 over x minus 1 dx. Throw in the two integrals, and anti-derivings should get us negative 1 over y on the left side, and as for the right, you could use substitute, but the interior function is just x minus 1, so the dx du substitution would be just a straightforward put the dx in the du's position, stick the natural log around the u, so we can go straight to the ln x minus 1 right here. Don't forget the plus c. This will become important in just a moment. So, now that we have an equation, we can go straight into plugging in the 2, 3 given in the question earlier. Usually I like to do that earlier rather than later, because otherwise this step can be very easy to forget. The left side becomes negative 1 over 3, and ln of 1 is just 0, so c therefore equals negative 1/3. With that, we can rewrite the equation, and all that's left to do is isolate y and make it a function. Throw the entirety of the right side beneath the 1, because we are reciprocating left and right of the equation, and then multiply both sides by negative 1, and you get y equals 1 over negative ln x minus 1 plus 1/3. And there you go, that's our answer. Notably, you could get rid of this fraction in the denominator here by multiplying top and bottom by 3. But the AP grading guidelines does not show that step, so it's likely that you can decide not to do it when it comes to the actual test. Also, as a final note, I'd like to say that if you happen to have time left over, a great way to check these types of questions is by plugging in the given coordinate points into your new equation and see if it pops in the right y value. It's a relatively easy step to do, and it will likely catch any simplification errors you may have done when isolating y, so yeah, highly suggested. Alright, that's all for now then. If you're still feeling shaky about one of the 3 topics covered in this video, there are some suggested FRQs in the description below, so be sure to check them out. Alright, till then, fellow human beings, good night, and good luck.